Imagine looking out over the rooftops of a city and seeing a canvas of living plants. All around the world, rooftops are going green, especially in cities. These rooftop gardens are an environmentally friendly option that is gaining popularity. Living green roofs have many advantages, including providing more space for agriculture, adding beauty to the cityscape, and increasing the air quality. During photosynthesis, plants remove carbon dioxide from the air and releases oxygen. Over the course of a year, a single 1.5 meter by 1.5 meter section of a roof, planted with grass, produces enough oxygen to keep one human breathing for a year. Another advantage of rooftop gardens is the fact that they absorb heat and insulate the building better than traditional tar and gravel roofs. Because they sit in the direct sunlight for many hours, the temperature of traditional rooftops tends to rise above the actual air temperature. Then they radiate that heat back into the environment. If you live in a big city or have been to a mall with a lot of concrete buildings during warm months, you might have noticed the temperature difference between those areas and the suburbs or more rural areas. That is because the heat is radiated back into the environment from the rooftops. An area with many buildings, like a city, can experience an increase in local air temperatures by as much as 5 to 7 degrees Fahrenheit. This phenomenon is referred to as the urban heat island effect. However, rooftop gardens might be able to diminish this effect. Measurements from the Chicago City Hall show that on a summer day, when the air temperature were in the 90s, areas of the roof covered in black tar rose to a surface temperature of 169 degrees Fahrenheit, while areas planted with a rooftop garden only rose to 119 degrees Fahrenheit. That is a 50-degree difference by Chicago Department of Environment. Now let's start our experiment. The first step of the experiment is to build the box houses. So the first thing you're going to do, you have to use a pair of garden clippers or strong scissors, whatever you bought or whatever you get. Cut out 2 pieces of tar paper that are the exact same size as the lids of your shoe boxes. Number 2, with the double-sided tape, attach the tar paper to the top of the shoebox lids. Number 3, place the lid of one of the boxes in the sod. Using the X-Acto knife, carefully cut around the lid to get a piece of sod the same size as the lid. 4, place the sod on top of the tar paper lid of one of the boxes. The box with the tar paper and sod lid will represent your rooftop garden house. The box with only the tar paper lid will represent your traditional house. The second step in the whole experiment is to measure the temperature in the boxes. The first step is to put the 3 thermometers you got all in one place. You can put it on a table or wherever you want, but with same amount of lighting and heating. And you want to put it there for just a great amount of 10 to 15 minutes. And then you will observe if the 3 thermometers read the same temperature. If they do, that means you're good. But if it don't, then you should use another thermometers. It is really important that your thermometers do not have wide variations in readings, because this would invalidate comparisons later.
but a variation of 1 degree or 2 degrees are okay. And the second step is to put 1 thermometer in each of your boxes. So the thermometers will allow you to record the indoor temperature of your box houses. If you are using probe thermometers, the probe part will be inside the box. Close the lid as best as you can over the cord and leave the digital reader part outside the box. Third step is to place the boxes on the same tabletop or counter with the same amount of lightings and heatings. You can put it at the same place you put for your thermometers. Number 4, you place the third thermometer on the table between the 2 boxes. This is your external thermometer and represents the outside air temperature around your box houses. There's no need to use a probe thermometers for reading the external temperature. Number 5, let your thermometers and boxes sit on the tabletop undisturbed for 30 minutes. While you're waiting, make a data table in your lab notebook. You'll record your results in the data table. So the data table may look like this. So you're going to have 5 columns and you're going to have 4 rows. In the first column, you leave the first column first row blank. On the second row of the first column, you write external. On the third row of the first column, you write internal of Rooftop Garden house. On the fourth row of the first column, you write internal of traditional house. On the first row of the second column, you write starting temperature in Fahrenheit, in degrees Fahrenheit. After 30 minutes, record the temperatures in your data table in your lab notebook. These are the starting temperatures. One at a time, open each of the boxes and quickly read the temperature on the thermometer. If you're using probe digital thermometers for inside your box houses, you'll be able to read the temperature without removing the lids. Read the temperature on the external thermometer. Do the box houses have the same starting internal temperatures? Are the internal temperatures the same or different from the external temperature? Next up, you should place a heat lamp above the box houses. Space the boxes and external thermometer such that they're getting equal light from the heat lamp. The lighted heat lamp will provide warmth and simulate what happens to the houses during a hot, sunny day. After about an hour under the lighted heat lamp, record the temperatures using the same technique as in step 7. These are the heated temperatures. If you're using a red alcohol thermometer, make sure to put the lids back on the box houses as quickly as possible to maintain the internal temperature. How do the internal temperatures of the box houses compare to the external temperature? Does the rooftop garden house get as hot inside as the traditional roof house? Number 10. When you're done recording your temperatures, turn off the heat lamp. This is as if the sun was set for the day. Then record the temperatures as the box is cooling down. After 15 minutes, record the temperatures using the same techniques as in step 7. These are the first cooling temperatures. Then wait an additional 15 minutes and make a second temperature recording. These are the second cooling temperatures. How quickly do the house boxes cool? Do the rooftop garden house and the traditional roof house cool at the same rate? Before really drawing conclusions from the data, Scientists should make sure their experiments are reproducible. So, you should repeat the whole entire experiment 2 more times for a total of 3 experimental trials. Now you should analyze your data. You should make a line graph for each trial showing the progression of temperature from starting to heating to cooling for each of the shoebox houses. On the y-axis, the vertical axis, put the temperature, and on the x-axis, the horizontal axis, label the progression from starting to heating to cooling. You should end up with 3 graphs, each with 3 lines, 1 for each shoebox and 1 for the external temperature, consisting of 4 data points, which are temperature readings. You can make the graphs by hand or use a website like Create a Graph to make graphs on the computer and print them. What do your graphs show you? Do you see a consistent pattern between repeats? Did the rooftop garden change the way the box house heated up and cooled down? If you have a rooftop garden on a building, would it help conserve energy?